Hello guys, today we will be solving CSES introductory problem set problem knight moves grid. So problem statement is there is a knight on the enclosed chessboard. For each square, print the minimum number of moves the knight needs to reach the top left corner. So we have an n cross n matrix. From the any position, we need to find the minimum move that it takes to reach the top left corner. So as we may have solved this type of problems already, but let's create a 3 cross 3 matrix. Right, we need to move a knight from this position to here. What are the possible ways? So one would be to we know that knight can move two steps in one way and one steps in its uh, 90 degrees, right? So it can, if it is here, it can move two steps here and then reach here, and or we can move two steps in this way and one step here, or two steps this way and here. And if you want to see the fastest way it can reach, would be two steps here and it will reach here, two steps here it will reach here, and here two steps here it comes back. I don't think it can in this. Let's see this example, maybe we can possibly, yeah. So from this position you can try moving one step, two step, one right, and I don't know. I'm completely blank. Let's open a chessboard. So here we can see a knight can move one step this way and two steps here. So I guess we are, if it is here, one step this way, two steps here, one step this, two steps this way, one step here, two steps this way, one step here, two steps this way, one step here, and one of the possibility was 4, and I'm really bad at chess, so maybe let's see, two steps here, one step here, and two steps here and one step here. Is it proper? But I don't know, it looks sketchy. Two steps here, one here, right? Okay. I get the hang of it. We can't move like, we can move like this, but here there should be, let's just see one more time, one step here, two steps here, right? So that's in total it will be 3, 1, 2, not possible, right? So the answer would be somewhere around 4. Let's see how we can solve. The way we can solve is, we know from here it's 0, and we need to find the next legal move, which would be this, I guess, and here it would be 1, and also it can move here, which is 1. From these ones we can find the possible ways knight can move and we can update it. So that would be the minimal, right? If we are starting from the root node, we can go each node breadthwise and find the minimum for each node. So let's write the solution. Our input would be integer of number, okay, and we'll initialize our chessboard. with I will insert -1 at first. So we got a n cross n chessboard with values of -1. Let me show you with the example we took 3 cross 3. You can see 3, 3, 3, 3, 3, 3. Okay. Now let's create a queue. Okay, we can, and we may need to have double-ended queue. So from collections, import dq, dq, dq. I don't know this spelling. Anyway, if it throws error, we'll see. Okay, it did not throw error, so and our queue will have values, right? So we'll create a list of 0, 0. So only for, as I mentioned, we will solve from 0 to, right, and everything. So we'll have, and also let's update chessboard of 0, 0 should not be -1, it should be 0. And now we'll create legal moves, right? Legal moves, that legal way, the way in, not legal moves, moves, right? The moves, the way the knight can move. So it would be, it can move 1 row and 2 column, and 1 row and -2 column. So it can move down, and it can go -1 comma 2, and it can go -1 comma -2. So these all are row wise 1. Now we'll do row wise 2, that is 2 comma 1, 2 comma -1, 2 -2 comma 1, and -2 comma -1. So these are the 8 ways a knight can move if the moves are legal. So what we do is, while our queue is not empty, we'll pop our element, that would be q dot, and we will pop from the left side, right, because that is the parent element, most parent, I don't know, I don't know, ancestor, highest ancestor, whatever, right? So we got our, and now from this row and column we have to move all the possible knight moves. That would be for row and current column. From, actually it's not, it's move row, move column, but okay, in moves row and expected row and column we can move. X column, I think we need to check few things, but we are off to good start actually. So the expected moves we can make would be would be row plus current row and row plus not row column plus current column. So here what we can do is, for these expected rows comma expected column, the value would be yeah, chessboard of row comma column, whatever the value the parent had, plus plus 1, and I don't know what I'm trying to do here. XC, I don't know. I honestly don't know. So and let's just append our queue with this expected row comma column. I guess that's pretty much it. Let's print for rows in our chessboard. Print. Let's just unpack each list, and that is it. Let's try to run it for 2 cross 2 because okay, we have an error. What is our error? Index out of range. Okay, right. So these are the expected moves, but these may not be the legal moves, right? It can be out of those box. So I don't know. I don't know why I didn't handle. So, and also we have minus, it can go into minus, that also we need to handle. So if 0 is greater than equal to expected row which is less than n, and 0 greater than or equal to expected column which is less than n, then do these operations. Now let's retry our solution. So 0 minus 1 minus 1 minus 1, yeah, there shouldn't be. Let's 3. Why is it stuck? I think stop. Did we go any situation that makes it loop? Probably not. But I guess we can add a chessboard of expected row and expected column. Should be minus 1. Let's retry. Okay, as expected. Okay, from here we actually have a possibility to, okay, let's tree to 1 position, to 1 position, to 1 position, and alright, okay, it works. And let's try for input 8 and validate. Okay, 0 3 2 and 4 5. Okay, and 54545456 54545456. Cool. Looks like the code works, and let's try submitting it. Let's try submitting it. I don't know. It is testing. It is testing. It is accepted. Pretty cool. Yeah, it was a simple solution to come up with. And thank you for watching.